becomes the open.
Okay. Yeah, my wife got me. Welcome to CrossTalk Waterloo. I'm your host, John Berry. On this show, we meet notable and engage in issues, meet notable people and engage in issues and events through all that touch all of us in the Cedar Valley in order to provide a greater understanding of the world in which we live. Issues are explored through facts, examinations, and options by examining the many facets of a subject. We hope to provide insight for a better informed and activated public. Let's make it happen. Be right back.
Getting healthy has never been
That
easier with
was
a
hard.
membership at Cedar Valley Sportsplex. Offering 80 free classes a week at all skill levels, there's always new and fun opportunities to grow. You never have to miss out on your favorites with our state-of-the-art facilities, featuring great exercise equipment, a track and field, pool, and 2 regulation gyms. So whether your game is football or pickleball, let the Cedar Valley Sportsplex turn your routine into something amazing.
When I ride my bike, I am always very careful and stay safe at all times. I always wear a properly fitted helmet. I check the safety lights in the front and back of my bike, and no matter where I ride, I keep an eye out for cars, even when riding on the sidewalk. This message is brought to you by Drive Safe Cedar Valley.
CrossTalk Waterloo. We have a special guest with us, Dr. Eugene Wallingford, who is the Associate Professor and Head of the Department of Computer Science at the University of Northern Iowa. Doc, I'm sorry for messing up that part of it, but thank you for coming. And you are our second guest and all that good stuff. I'm not going to read your bio. Your bio is outstanding, but please let our viewing audience know a little bit about you and how you ended up at University of Northern Iowa. Okay. So you have the floor.
All right. Well, I'm originally from Indianapolis, Indiana. I did my graduate work at Michigan State University, where I studied computer science with a specialty in artificial intelligence. And upon graduating there, I was hired as a faculty member. at the University of Northern Iowa. The Department of Computer Science came into existence in 1992, and I was the first new faculty member hired into it.
Wow. So you've been there a while.
I've been there for a while.
Yeah. And that is our topic today is artificial intelligence. And when my esteemed and outstanding executive producer, William Kay, and I talked about this, the first 2 questions out of the chute, Doc, is just what is artificial intelligence? We hear it banted about a lot in media, and folks talk about it in print. But exactly what is artificial intelligence for neophytes and novice?
It's a hard term to define because there isn't a single definition that anyone has. So, in the history of AI leading up to what we do now, there's always been a fascination with trying to program computers to solve the sorts of problems and behave in the same ways that humans do. And I think that's the general theme of AI. So trying to solve problems that if a human solved the problem, we would consider it to be intelligent behavior, that would count. It's a little bit of a moving target, though, because every time, it seems that every time we solve a problem and we're able to do something with a program, say, oh, that's not AI, because really AI should be something more. But I think that gives a pretty good sense of it.
And keeping in that vein in terms of the definition of artificial intelligence, how is it different at this particular juncture in human intelligence, artificial human intelligence, and as we know it, human intelligence? You and I conversing now. What's the difference?
Well, historically, computer programs that we tried to solve hard problems with were rule-based. So if we somehow, if you were an expert in a particular area, I would sit down with you and try to understand the knowledge you have about the problem, and then encode that in a computer program to solve a similar sort of problem. Human intelligence may work that way, but it doesn't work that way at the very lowest level. Our brain is really a massive number of neurons with a massive number of connections doing pattern matching. Our memory is a pattern match, and how we solve problems seems to be done with neurons firing with pattern matches. And it, at least for many years, it was very difficult to try to build a computer program at a scale large enough to simulate how the human brain worked.
Wow.
So we worked with rules of various forms. Computer hardware has gotten faster. Our understanding of software and algorithms has gotten better, to the point that we're now able to start to mimic some of the pattern matching capabilities of our brain. And a lot of the advances that we hear labeled as AI in the last few years, I think really have been in that vein of massive data sets and finding patterns in them.
So, in essence, we are trying to recreate what over tens of thousands of years of evolution, an artificial brain, if you will.
Yeah, we don't really, so in comparing it to a human brain is a little bit difficult. We don't understand completely how the human brain works.
You heard that first here.
Yeah. I mean, biologists are studying it at one level. Psychologists, cognitive psychology studies it at another. I think a lot of the motivation for AI as a discipline comes from the cognitive side of things. People examining their own thought processes and saying, well, I can play a game of chess. Maybe I could write a program that could play a game of chess in a similar way. And so, to the extent that we're modeling the human brain, a lot of times it's trying to figure out what some of the higher level cognitive structures of how our brain operates. Yeah, how they work. Okay. And so, as a graduate student, I studied a lot of computer science. I studied some philosophy, and cognitive psychology was really a place where it was interesting to see how psychologists would use the computer as a metaphor for how the human brain works, and that allowed us to understand some of the architecture of how we think. It's not a complete picture. There are a lot of things that happen in our brain that we have a hard time fitting into that model. So we're still learning on that side as well.
Yeah, I had an anatomy and physiology professor that said that the human body is so magnificently, simplistically complex. And that's a conundrum, if you will. Doc, can you tell us some of the forerunners of artificial intelligence? Was it a particular nation? Some folks think it was the nation in Japan or universities here. I know that Carnegie Mellon. Who would be the forerunner as it relates to artificial intelligence?
Well, if you're willing to go far enough back, we can trace it. Back? We can trace it to ancient philosophers thinking about thinking. Okay. The sorts of things that we think about now. One of the earliest mechanical computation devices that we know a lot about is Charles Babbage's analytical engine. He was a British inventor, and he built a mechanical device that could do computation. At that point, they could begin to write programs that would drive how this computer worked. It wasn't very complex, couldn't do very much. But even then they were thinking about, well, what would it be like if we could program this computer to do things, at the level of complexity that humans do. But really, I think you can only go back into the last century to find where AI began. The term was coined at a conference at Dartmouth College in 1956 in the summer. A group of academic researchers from places like Stanford and MIT, Carnegie Mellon, Rochester in New York, who were all working on similar kinds of problems. They got together to kind of talk about what they were doing, and one of the researchers used the term artificial intelligence. If you want to take it a little further back and really focus it a little bit, I would take it to a man named Alan Turing, who you may have heard of from the movie The Imitation Game a few years back. Alan Turing was a mathematician in Britain, and he made several advances in that led to the discipline of computer science, so computational theory. But he also was thinking about what it would be like for a computing machine to behave intelligently. So he was the first person we know of who proposed writing a program to play chess, which for many years was sort of the goal of AI. It was very complex. We think of it as a complex intellectual game. And in the late 30s, early 40s, he wrote a paper called Computing Machinery and Intelligence, where he speculated on what it would mean if we wanted to call a computer or a computer system intelligent.
You mentioned, Dr. Wallingford, machine, and one of my questions as it relates to artificial intelligence, we somewhat know how the military has started to explore DAPA, artificial intelligence, and we hear bantered about the term algorithms and as it relates to military application. What do you think are some of the civilian or public good applications that will derive from artificial intelligence as we continue to learn more about it and to build on the theoretical constructs of just what is artificial intelligence?
So in this regard, I think AI is not much different than the rest of computer science. So the earliest digital computers were created with the primary purpose of computing trajectories and planning military action. But it didn't take long for those machines to start being used in businesses to do business data processing, and it created a whole new world for how to solve certain kinds of problems and kind of revolutionize the 20th century. It's hard to describe AI because at the end of the day, an AI program is just a computer program that does something. So the question is what makes it different from some other computer programs, say?
Well, we have Watson, which is IBM, and the applications that it's showing how it's helping corporate America check on various for instance, jet engines and when you need to replace something. The human benefit is where I was going with. What do you think the human benefit of artificial intelligence as it advances?
I think the human benefit for AI will be similar to what is happening. The ability to write programs to solve problems helps us in every facet of our life. So the smartphone you have in your pocket is an incredibly powerful computer compared to computers we had not that long ago. And it does all sorts of interesting things to make your life better, between media applications that let you communicate with others, but also mapping applications and data applications. AI programs will be able to help in a broader set of applications. So, right now there's a limit to how much a business data processing system can do. Doing just say an accounting application, but if I can take all of the data that I amass as a part of my business and I can find patterns that help me to target my sales or marketing, I will be able to do my job better. A lot of AI starts in games. So you mentioned Watson. Watson was originally designed with applications in mind, but it started as a program that played on the game Jeopardy. 7 or 8 years ago, it won. They invited back Ken Jennings, who had won 5 consecutive games on Jeopardy, and they brought back another gentleman who was the all-time money winner in Jeopardy, and the two of them played a 2-day battle against IBM's Watson. And there, Watson had to do the sorts of things that humans have to do. It had to read and understand questions, figure out what the question meant, search its mind, search its data to find the answer, and then present an answer back.
How far out do you think with President Bush 41 passing, the dog Sally, who was a help for the president, I think there's a misunderstanding, also perhaps a fear, and then there's schools of thought that once we marry artificial intelligence and robotics, there's some fear there. What do you think about that? Obviously, we've had the scary movies.
Sure. So I've been in AI for a long time. I started when I was an undergraduate, so 30 some years ago. And there have always been fears that AI programs would somehow take over the world and subjugate humans or something like this. I think practically we don't have much to worry about right now. We're not really close enough to solving those kinds of problems. AI applications right now are still pretty narrow. I mean, they solve very specific problems. And when you step outside of the bounds of that problem, the programs are completely useless. So Watson's great at doing a certain kind of question-answer problems. So for doing diagnosis and helping, doctors do research for cancer therapies and so on. But it can't replace a businessman. It can't do a lot of things right now.
Right now, and I think a lot of experts, such as yourself, stop at that river's edge, if you will, because you can't really peer into the future to the point of maybe 400 or 500 years from now, half a millennium.
Half a millennium, things could happen by then. So certainly things could change in 400 or 500 years.
And I think that there are some notables now. Bill Gates happens to be one that comes to mind, and the astrophysicist who passed, and I'm blanking on his name.
Stephen Hawking.
Stephen Hawking.
Sure.
They are and have said we need to be leery of artificial intelligence. Speaking of that, and the good part about artificial intelligence, what are some of the things that you're doing at the great University of Northern Iowa as it relates to studies and furthering the advancement of artificial intelligence?
Well, we have a couple of different faculty who work in AI at least part of the time. My research background was in trying to build systems that could integrate rule-based reasoning with case-based reasoning. So, in some domains we have a set of rules we can write down, and that can help us solve a problem.
If then what? That is just
right.
an
If then type rules are a very simple way of stating it. But if you think about a domain like the law, for instance, we do a lot of case-based reasoning. So a new situation comes to me. A judge's job is not to apply a set of rules to it and say this side's right, this side's right. They look at case law and they say, well, this case matches several other cases, and it matches most closely to this one. And in this case, we decided that it favors this party to the suit, and so in this case, we'll make the same decision. And that's a very different kind of reasoning, but we also use that kind of reasoning when we're doing design of buildings and artifacts, and when we do diagnosis. And so we were trying to build systems that could do that kind of reasoning. We have another professor we hired who worked in the early days of what are called recommender systems. So when you go to Amazon, and it always says, people who like this also buy these things. He was doing early work with movie databases where you go in and say, I've watched these 5 movies, I thought these 2 were really good, I didn't like these 3, and it could recommend movies to you.
Pandora uses that kind of.
But that kind of recommender technology is now quite common. And Dr. Schaefer, who's one of our faculty members, that's his background. These days, I think most of the work that we're doing with AI is more related to machine learning, because that's what our students are most interested in, and the sorts of things they'll see when they go out into the workplace.
Smarter machines.
Well, machines that can find patterns and learn to be better at the thing that they're doing. So last couple of years, we've had students working in our projects courses building systems with a package from Google called TensorFlow, which allows them to build big systems that do deep pattern matching in large sets of data. And one of the applications they worked on was a challenge from the National Institutes of Health, where given a bunch of X-ray data, could we figure out more quickly whether this image contains evidence of a cancerous tumor, say, where humans maybe had missed it at first, but we later knew that there was a tumor there. So trying to mine the data, and by giving it lots of examples, programs can learn to get better at a very specific task that they're trying to solve.
But the other side, the negative side that some folks fear about artificial intelligence is exactly what you are explaining.
Sure.
When artificial intelligence will learn by itself to understand various aspects of what it's looking at and has made a decision, a determination, where are we going with that? I'm hearing it interwoven here that artificial intelligence, the next phase would be for it to learn from itself, from its own experiences, just like a 2- and 3-year-old learns.
Sure. And we've people in the discipline have been working on those kinds of problems for a long time. One of the reasons I'm not quite as worried as some other people are, at least in the short term.
Not yet.
At least in the short term, is that we've been thinking we're just around the corner from those kinds of advances for a long time, and it's really taken a while, and we're not that much farther along. Certainly, in the last 5 or 6 years, we've seen programs that do learn to solve pretty impressive problems from scratch.
So where are we with normal applications? The Amazon and the various apparatus in the home where it says turn the music down, turn it up. Folks are saying that our cars are getting smarter than we are, and that more or less a vertical integration of everything that our daily existence. How far are we from having a fully smart home car? I often say that twofold question, that my and your license won't be the same as my granddaughter, who's just 3 going on 4.
Right.
So where are we going with this in terms of that the home has to be rewired, everything from the toaster to the refrigerator is getting smart now?
Sure. So I don't think we're very far at all from having the ability to do that. I think within a few years we'll have self-driving cars, and big parts of the ability of a self-driving car have been learned by the car. So we're training these programs by having them drive and giving them feedback, much in the way you would help anyone learn. You have them try a task, and when they get it wrong, you provide some corrective feedback, and when they get it right, you let them know that they've done correctly. So I think our cars already have millions of lines of software in them. I think the big change is going to be in the next few years. Right now, those lines those lines of code are all in different subsystems. So our braking system, fuel injection, they're all separate bits of code. The first big step, and you see companies like Tesla trying to take this, is have a single integrated software system that's driving everything. And so now the sensors on the wheels and lights and so on are much like our sensors, feeding to a central processing unit that's doing everything.
Which would be the brain.
Right.
The one thing that folks will say about that when an artificial intelligent car that's more or less driving it, what happens when I need to take control? We know that the modern day aircraft, commercial aircraft, basically flies itself.
Yes.
But when does the human element have to take control? As for an example, prime example, the miracle in the Hudson.
Sure.
When the captain had to take controls. So what happens if the computer fights you? I keep going back to more or less science fiction, but we're getting there to the point where the computer says, no, I got this, if you will.
I've read a lot of science fiction, so I know, I've read the speculations. I don't know what will happen. New technologies happen, and we learn to cope with them as they become part of what we do. So we invented the atomic bomb before we were maybe prepared for figuring out what to do with it. We hadn't planned, what are the ethics of this. We took some actions, and we sort of reached an ethical agreement among ourselves. I suspect that this technology will be very similar to that. As the technology becomes more pervasive and more powerful, able to do more things, we're always going to have a set of people who are thinking about this and talking about it. I think it's important for the computer science students and the people who are part of integrating software into the tools we use on a daily basis, who are thinking about these ethical issues.
Are they though?
We're starting to see more and more.
Okay, well, scientists, and I get it, they just want to make sure that this works, and that's their baby, if you will. And then the ethicists say, hold it, thou art only mortal, that vertical integration. A couple of other questions as it relates to the greater Cedar Valley. What are some of the corporate sectors doing, and are they partnering with the University of Northern Iowa, with your department, as it relates to artificial intelligence, in terms of the corporate sector here?
A lot of companies are applying AI to help them solve problems. In particular, big data processing and finding patterns right now. I think that's the biggest applications that are going on. A lot of manufacturers are doing more and more with robots, and robots can, and as we create robots that can be more autonomous.
Robots.
Sure.
There we go.
Robots can be autonomous. They can move around. They can move around a factory by themselves and make some more decisions. They certainly can help users do a better job there. We don't partner directly with any of them on research, though we interact with a lot of them through alumni and various civic initiatives that the university is involved in.
And I'm sort of going back to in closing, should society be a little leery of it and always find a way to, I'm going to be very elementary with this aspect of it, of the ability to pull the plug on artificial intelligence?
I think AI is different than other technologies in that
it might be a little difficult to pull the plug.
Right. It's different in that it promises a different kind of agent, an agent at the end that's solving problems. The more it becomes like us, perhaps it starts to think more like us, and we will have to be thinking about those issues all the way along. As I said, we have a while because we're not really close to the point of computers being able, any programs being able to, they're not self-aware. They don't think of themselves as a thing. There's no consciousness that goes. And so, but I think, as with any other technology, we need to be thinking about it. And I think it will develop naturally as AI programs become more a part of what businesses do and use, and what our government does, and what we do in our communications. We're going to come in more and more contact. So you're starting to see this now with bots on Twitter or Facebook, which aren't really all that intelligent, but they pretend to be like other humans, right? They like things and they post things. And I think a bigger concern in the near future, and it'll help us wrestle with the bigger problems, is that it's going to be harder and harder to tell real information that's posted on Facebook from fabricated information because it's created. Right now it's easy to do that with text, but what about images?
Well, we're going to have to stop here and bring you back with this frightfully informative topic. And thank you so much, Dr. Eugene Wallingford, for joining us here on CrossTalk. A final note as it relates to CrossTalk: winners never quit and quitters never win. Thank you for taking the time to join us. Until next time, on behalf of myself, John Berry, and staff, we ask you to stay informed, stay engaged, and stay with us next time on CrossTalk Waterloo. Take care.